Today, we're diving into the invisible world that connects us all. Seriously. Every time you send a text or stream a movie, you're tapping into this vast, unseen web of wireless networks. But how does it all actually work? Well, let's follow the signal and find out.
I mean, really think about it for a second. You tap on your screen, and just like magic, information flies across the room or maybe even halfway around the world with no wires anywhere. It's wild. So today, we're going to follow one single piece of data on its amazing journey, from your device, right through the air, all the way to its destination.
All right, first things first, let's get on the same page. What are we even talking about when we say wireless network?
At its core, it's actually a pretty simple idea. Instead of a physical wire, we use radio waves, this invisible energy, to carry our information. You can almost picture your data just riding on these invisible waves zipping through the air. It's this basic principle that frees our devices from being stuck to a wall and gives us the awesome mobility we all love.
And believe me, these networks are absolutely everywhere. It's not just the Wi-Fi in your house. It's the huge cellular network that covers our cities. And it's even that tiny Bluetooth signal that connects to your headphones. It's this invisible backbone that, honestly, our modern lives completely depend on. So we've got data sitting on our device. How in the world does it make that jump into thin air? Well, that's where something called the physical layer comes into play.
Okay, so for our data to go anywhere, it needs a highway. And that highway is called the radio frequency spectrum. I want you to picture this massive, invisible highway system in the air all around us. It's a limited resource, so it's carefully divided up into different lanes, or frequency bands for different things. You've got a lane for Wi-Fi, another for 5G, even lanes for stuff like your car's radio.
And here's how that great escape actually happens. Your phone takes your data, all those ones and zeros, and it basically piggybacks it onto a specific radio wave. Then the antenna in your device acts like a little transmitter and just broadcasts that signal out into the air. And just like that, our data packet is officially airborne.
Now you'd think with billions of devices all shouting signals at once, it would be total chaos, right? But it's actually pretty orderly, and that's all thanks to some really important infrastructure and some crucial rules of the road. So on its trip, our little data packet is going to meet a few key players. It starts at what's called a user terminal. That's your phone or your laptop. From there, it travels to an access point. Think of your Wi-Fi router at home. And that router connects it to the wider network infrastructure that's going to guide it the rest of the way. So how do all the different devices on your Wi-Fi network avoid talking over each other? Well, that's the job of something called Medium Access Control, or MAC. You can think of it like a traffic cop. It's a set of rules that tells each device when it's clear to send its data. It's the reason the Wi-Fi in a busy coffee shop doesn't just crash into one big digital traffic jam.
Now, the kind of highway our data takes really depends on where it's going. If you're just connecting your earbuds, which are only a few feet away, it'll use a personal area network, or WPN. That's Bluetooth. For your house or your office, it's a local area network, or WLAN. Yep, that's your Wi-Fi. And for connecting when you're out and about, it's a wide area network, a WWAN, like the 5G cellular network.
But, this journey, it's not always a smooth ride. Traveling through the open air is risky, and our little data packet has to face a bunch of dangers along the way. And these are the three big ones. First, because the signal is just out there in the air, it can be picked up by eavesdroppers. Second, it can get all messed up by other signals, which causes interference, basically a traffic jam. And third, the highway itself might just not have enough lanes or bandwidth for everyone trying to use it.
You've probably felt this yourself, right? If you live in an apartment building, your Wi-Fi router is basically in a shouting match with signals from all your neighbors' routers, maybe their microwaves, their Bluetooth speakers. All of that stuff creates this kind of digital noise that can really slow your connection down to a crawl.
Okay, so that sounds a little bleak, but here's the good news. Engineers have spent decades coming up with some brilliant ways to get around these challenges, making our networks way faster, more reliable, and a whole lot more secure. So, to fight back against those eavesdroppers, we use this amazing thing called encryption. You've probably seen WPA2 or WPA3 in your Wi-Fi settings. Well, that acts like a secret code or a digital envelope for our data packet. So even if somebody manages to grab the signal out of the air, the information inside is just scrambled nonsense without the secret key. And just look at how far we've come. It's incredible. We started with 1G networks that could barely handle an analog voice call, and now we're at 5G, which is so fast it's powering the Internet of Things, connecting everything from cars to coffee makers.
Every single generation here represents a huge leap forward in using our airwaves more and more efficiently. This chart really puts that more lanes idea into perspective. The jump from 3G to 4G wasn't just a little step up, it was a massive leap in how much traffic the network could handle. We're talking about a highway that is 5 to 20 times wider. That's the difference between a little country road and a massive superhighway. But what happens when there's no infrastructure at all? No routers, no cell towers, nothing. What then? That's where these amazing things called ad hoc networks come in. In these setups, devices talk directly to each other, passing messages along almost like a bucket brigade. They are super resilient, which makes them perfect for things like military operations or disaster relief when normal networks are completely down. So, our little data packet made it. It navigated the highways, it followed the traffic laws, dodged all the dangers, and reached its destination. But the journey for wireless technology itself, oh, that is far from over. The future is really about connecting, well, everything. The Internet of Things is going to bring billions with a B of new devices online. We're going to have machines talking directly to other machines, and we'll have technologies like cognitive radio, which will create these super smart networks that can actually sense which lanes on the Spectrum Highway are empty and just start using them automatically. It's going to make the whole system way more efficient.
And that leaves us with this one final and really important question. These invisible highways in the air around us are getting more and more crowded every single day. So the biggest challenge for the next decade is going to be this. How do we find new, smarter ways to manage this limited resource, to make sure our connected world stays connected? Thanks for following The Signal with us today.